Dear viewers, welcome to Chemistry with Fun. Today's topic is radioactivity, lesson 5. Today we will discuss law of radioactive disintegration. In lesson 1, we have started the definition of radioactivity. From that definition, we know that any unstable nucleus disintegrates to form a stable non-radioactive product. The law of radioactive disintegration shows that the rate at which a radioactive nucleus disintegrate and the rate depends on which factor. Okay, let's start. The rate at which a radioactive isotope disintegrate is disintegrate at a particular time is directly proportional with the number of radioactive atoms present on that isotope on that particular time. It does not depend on the initial number of the isotope. Means law of radioactive disintegration shows the rate dependence on which factor? The rate of a radioactive isotope depends is directly proportional with the number of radioactive atoms present on that particular time. Means if a radioactive isotope is disintegrate, it depends on the number of the atoms present on particular time, on which time it's disintegrate, not depends on the initial number of the atoms. Okay, means the rate depends directly proportional with the number of radioactive atom present at the particular time when the radioactive isotope is disintegrate, but it does not depend on the initial number. If a radioactive isotope starts disintegrate 2 minutes ago, but at the present time the rate of disintegration depends on the number of the radioactive atom present on the sample in present time, not the number of the radioactive atom present 2 minutes before or 2 minutes ago. It depends on the number of the sample at the present time. It does not depend on the initial number. and the rate does not depends on external factor, that is temperature, pressure. We know that radioactive property is an internal property, nuclear property. From the definition we have know that. So it does, the rate of the disintegration of a radioactive isotope does not depends on external factor, temperature, pressure. It does not depends on external factor. Okay. Now we come to the mathematical derivation of radioactive disintegration law. Mathematical derivation of radioactive disintegration law. Okay. Let a radioactive element or substance starts to disintegrate. After time t, after time t, the number of atoms present in the radioactive isotope is n after starting disintegration. When the disintegration starts, after T time cohort, let the number of radioactive isotope present is n. Then from the law we know that the rate of radioactive disintegration is directly proportional to the number of atoms, radioactive atom present on the particular time. It does not depend on the initial amount. So at very small time in dt, let dn number of atoms disintegrated. Okay. At very small time dt, dn number of atoms, radioactive atom disintegrate. So rate means dn by dt, dn by dt it is directly proportional with the number of radioactive isotope present at that particular time. Means at dt time the number of radioactive isotope present in the nucleus is n. It is directly proportional is n. Here one negative sign is provided because it is disintegrate, because the number of atoms is decreasing, so negative sign is provided. To to omit the proportional sign, we have to give a proportional constant, or dn by dt equal to minus lambda n, lambda equal to proportional constant. Which is known as disintegration constant. Okay. If we evaluate the equation, dn by n equals to minus lambda dt. If we integrate both sides, as lambda is constant, so it is outside of integration dt. Integration of dn by n is equal to ln n equals to minus lambda integration of dt equals to t plus c. C is equal to integration constant. C is equal to IC, integration constant. ln n equals to minus lambda t plus c. C is equal to integration constant IC. When the radioactive reaction disintegration starts, when the radioactive disintegration starts, at the starting time of disintegration, then T will be 0, and let the initial number of radioactive atom n equal to n equal to n0. Then when t equal to 0, put the value in this equation of t, then ln n0 equal to lambda into t is equal to 0 plus c. Then c is equal to ln n0. Put this equation value 1. Putting the value of C means integration constant in equation 1, we get ln n equals to minus lambda t plus ln value of C equal to ln n0 then ln n by ln n0 equal to minus lambda t, or ln n by n0 equal to minus lambda t. Okay. Then n equal to n0 e to the power minus lambda t. It is one mathematical derivation. N equal to n0 e to the power minus lambda t. If we calculate the value of lambda from this equation, then lambda equals to 1 by t ln n0 by n. Then if we convert ln into log, then lambda will be 2.303 by t log n0 by n. Okay. Let's take when the radioactive disintegration starts, the initial amount of radioactive isotope is A gram. Let when the disintegration started, the initial amount of radioactive isotope is A gram. After time t, it dissociates disintegrated X gram. Then left amount equal to A minus X gram. Okay. When the disintegration started, the initial amount of radioactive isotope is A gram. After time t, when the disintegration is going on, it disintegrates X gram. Then left amount will be A minus X gram. From the law, we know that the rate of radioactive disintegration, it depends only the number of the radioactive isotope present on that particular time. So putting the value A and A minus S in this equation, lambda will be 2.303 T log initial amount. We n0 is the initial amount, here initial amount is A, so A, and n is the present amount, here present amount is A minus X. This. Okay. This is the mathematical derivation of law of radioactive disintegration. If we want to calculate T from this equation, then T will be 1 by lambda ln n0 by n, and in this equation T will be 2.303 by lambda log n0 by n. Okay. Lambda equal to disintegration constant. Now we come to the half lifetime period, means T half. Half lifetime period, which is denoted by T half. What is half lifetime period? When a radioactive nucleus starts to disintegrate and at the end it converts to a stable non-radioactive product. But in this way, at a particular time, the amount of radioactive substance present in the nucleus is half with its initial amount. That particular time is called half lifetime period of the nucleus, when the amount is half with its initial amount of the radioactive substance. Means the particular time when the radioactive substance become half of its initial amount or its time of disintegration, its time of starting of disintegration. Okay, that is called half lifetime period, denoted by T half. Is called half lifetime period, denoted by T half. What is half lifetime period? Now, when a radioactive substance after starting disintegration become half of its initial amount, it is called half lifetime period. That particular time is called half lifetime period of the radioactive substance. But the half lifetime period is not equal of all radioactive substance. Some radioactive substance half lifetime period is few high, and some radioactive substance have half lifetime period is few low or too low. The radium half lifetime period is 1590 years. Let's calculate the half lifetime period. From the derivation of law of radioactive disintegration, we calculate lambda equals to 1 by T 2.303 by T log N0 by N. From its, if we calculate T, then 2.303 by lambda log N0 by N. As we want to calculate half-life time period, then N0 here to initial amount, N the number of substance present at the present time or particular time. If the time become half, then N will be half of it. N0 will be half. N0 is the initial amount, and the at part T half, the N0 will be half of its initial amount. Then at T half, N will be N0 by 2. Then putting the value in this equation, T equal to T half 2.303 by lambda log N0 by N0 by 2, or T half 2.303 by lambda log 2, because it's alter N0 into 2 by N0. N0 cancel to log 2, or T half is equal to 2.303 by lambda, value of log 2 equals to 0.301. Okay. Then T half will be 0.693 by lambda. It is the equation. From this equation, we can conclude that the half-life time period of a radioactive nucleus, that is T half, is inversely proportional with the disintegration constant, because 1 by lambda, 0.693 by lambda. So from this equation we can conclude that the half-life time period, that is denoted by T half, is inversely proportional with disintegration constant, that is lambda. means because T half equal to 1 by lambda. Now we come, half lifetime period is concluded. Now average lifetime period. Average lifetime period, something average means the sum of all numbers by divided by the total numbers. Average lifetime period. Which is denoted by TAV, average. All the radioactive nucleus does not disintegrate at the initial time or at infinite time. The rate of disintegration of different radioactive nucleus is different. Something disintegrate at starting moment and some radioactive nucleus disintegrate at few times later. If we want to calculate the average lifetime period, then we have to summarize the all lifetime of the radioactive nucleus, the sum divided by the total number of radioactive nucleus, because all the radioactive nucleus is not dissociate or disintegrate at same time. As all radioactive nucleus does not disintegrate at same time, some of them disintegrate very early or some of them takes infinite time. So as some of them disintegrate very early or some of them infinite time, so here a range become where a radioactive nucleus disintegrate from early to infinite time. It is statistical one. So to calculate the average lifetime, we have TAV equal to T1 dN1 plus T2 dN2 plus T3 dN3 plus dot by dN1 dN2 plus dN3 plus dot. It means to calculate the average lifetime period, the sum of the all lifetime of radioactive nucleus divided by the total number of radioactive nucleus to be disintegrated. The sum of all lifetime of all radioactive nuclei is divided by the sum of the number of radioactive atoms to be disintegrated. T1 is the lifetime of radioactive nucleus N1, T2 is the lifetime of radioactive nucleus N2, here T3, N3, and the number of the radioactive nucleus which would be disintegrated is N1, N2, N3. Okay, then T average will be T average will be 0 to infinite Ti dni by n0. Here the limit 0 to infinite, because we know that any radioactive substance disintegrate at initial time, or any radioactive substance takes the time infinite, or any radioactive substance disintegrate in this range. So we summarize all the range from 0 to infinite, and here n0 because number of total nuclides to be disintegrated from 0 to infinite. n0 is the initial number of the radioactive substance to be disintegrated. It is denoted by n0. Then dni is the number of radioactive substance to be disintegrate, of which lifetime is Ti. Then from the mathematical derivation of radioactive disintegration law, we know that minus dN by dt lambda n, or minus dN by n equals to minus lambda dt. Okay. Or integration of dN by n equals to minus integration of lambda dt. Or ln n equals to minus lambda t. Now from this line we get dn equals to minus lambda n dt. And from the mathematical derivation we found the value of n equals to n0 e to the power minus lambda t. Putting the value of n in this equation 1, we get dn equals to minus lambda, value of n equal to n0 e to the power minus lambda t dt. The value of n in equation 1. Okay. Here the negative sign is neglected because n is a positive quantity, because the number of atom, negative sign is neglected because the number of atom is a positive quantity and the number of radioactive nuclide is decreasing with increasing the time t, because the number of radioactive nuclide is a positive quantity and the number of radioactive nuclide is decreasing with increasing time t. T average will be 0 to infinity t dn by n0 integration of this. Putting the value of dn in this equation, we get T average 0 to infinity t into lambda n0 e to the power minus lambda t dt by n0. Here one negative sign is eliminated because the number of nuclide is positive and the number of radioactive nucleus is decreasing with time t. Here n0 is cancelled, then t average will be 0 to infinity t lambda e to the power minus lambda t dt. T average, lambda is integration constant, so it is outside of the integration. 0 to infinity t e to the power minus lambda t dt. This integration is solved by bypass method. Then T average equals to lambda T U into VDX. Bypass method formula is U into VDX. The T is U, V is e to the power minus lambda T. U into e to the power minus lambda T dt minus dd U minus ddt of T into to the power minus lambda t dt whole dt 0 to infinity. Then by solving the equation we get T average will be lambda here T e to the power minus integration of e to the power lambda t minus dt e to the power minus lambda t by minus lambda minus integration of derivative of t is 1 dt by dt equal to 1 integration of e to the power minus lambda t by minus lambda zero to infinity dt. T average equals to lambda t e to the power minus lambda t by minus lambda minus e to the power minus lambda t minus lambda into minus lambda lambda square 0 to infinity. For T average equals to lambda, if we put the value 0 to infinity, then we get one by lambda square, or T average equals to 1 by lambda. Then from this equation we know that the average lifetime period of a radioactive nucleus is inversely proportional with disintegration constant. Now we calculate the average lifetime period, we calculate the half lifetime period. Now we come the relation between average lifetime period and half lifetime period. Relation between T half lifetime period and TAV average lifetime period. From half lifetime period we calculate that half lifetime period is T half, the value is 0.693 by lambda, and this is dotted by equation 1, and average lifetime period equals to 1 by lambda. If we calculate the relation between them, let's take 1 divided by 2. 1 divided by 2. Then T half is divided by T average. Then 0.693 by lambda equals divided by 1 by lambda. then lambda is cancelled, or T half by T average equal to 0.693, or T half equals to 0.693 into T average. It is the mathematical relation between half lifetime period and average lifetime period. Half lifetime period of a radioactive nucleus is 0.693 into of its average lifetime period. Okay. And unit of radioactive disintegration is time inverse. Okay.